What's up, guys? A lot of you guys have been approaching me and asking for the solution to a particular differential problem or differential equations problem for Engineering 311. And so I figured I'd take a moment and solve it for you guys. So the problem that I'm speaking about is this one. Now, before I begin the solution, I have to tell you that this is a very typical problem that you should all know how to solve. So if you got stuck on this problem, obviously learn from your mistakes, but my recommendation is that you should do at least 5 to 10 extra additional problems on differential equations, as they make for good midterm problems, good final problems. They test you on a whole slew of things that you should know about. So let's begin the process. Now, it's all about knowing your cheat sheet well enough, knowing how to apply your cheat sheet well enough to take this particular problem, transform it into its Laplace domain, isolate for capital Y, which is a function of S, and then take the inverse Laplace to get the solution. So everything I said, most of you guys should already know and understand. Let's begin the process. So if we take a look at our cheat sheet, it turns out that the following row shows us exactly how to take the Laplace transform of derivatives. Now specifically, it's this row here that you guys need to understand. If you understand it well enough, then the two rows above it are not necessary, right? Because they are encapsulated in the general equation for the Laplace transform. So really understand the one I've highlighted in yellow, and then the ones above are going to become unnecessary. So if I apply this to the left-hand side of our equation, let's go get that equation again. Here is what we are going to get. So the Laplace transform of y double prime is going to become s squared capital Y minus s little y of 0 minus y prime of 0. The Laplace transform of 3y prime is going to be 3, open bracket, s capital Y minus y of 0. The Laplace of negative 2y is just going to become negative 2 capital Y. And now it's the right-hand side that we need to deal with. So there are different ways to go about doing this. If your teacher allows you to get a full-out cheat sheet, the one that you can find at the back of your book, well, then there is a formula there that allows you to do this immediately in one shot. However, I'm assuming that is not the case. And so you have options. You can either take the Laplace transform of t and then deal with the e afterwards, or take the Laplace transform of e to the negative 2t and deal with the t afterwards. You should know what I mean when I say deal with the t, deal with the e. These are all things that, you should understand, as there are rows in the cheat sheet that explain exactly what needs to be done. So for example, the approach I will take for now is I'm going to take the Laplace transform of just t. So the Laplace transform of just t from my table is going to be 1 over s. And now I'm going to deal with the e to the negative 2t term. By the way, it's not 1 over s, it's 1 over s squared. So now I'm going to deal with the e to the negative 2t term. And in order to do this, let's take a look again at our cheat sheet and realize that if I have something that has an e to the t being multiplied in it, here is the effect in the Laplace domain. So whenever a function is being multiplied by e, well then in the Laplace domain, it is going to create a shift. So the blue highlight is what you need to understand here to deal with the e to the negative 2t. You should understand that what will happen over here is we are going to essentially replace every s by s plus 2. And so this is how this problem is going to begin. The rest of the steps, or the next set of steps, are going to be to isolate capital Y on the left-hand side. So let's go ahead and replace y of 0 by 0. Let's go ahead and replace y prime of 0 by negative 2. And so our next line becomes the following. So if I take the 2 and also multiply it in, I will be left with 2s squared capital Y plus 4 plus 3s capital Y minus 2y equals 1 over s plus 2 all squared. If I take the 4 to the right-hand side and I factor out capital Y, here's what I get. So capital Y factored out will give me 2s squared plus 3s minus 2. And the 4 will go to the right-hand side. So in our effort to isolate capital Y, we are going to now divide both sides by 2s squared plus 3s minus 2. Obviously, at some point, we're going to want to factor that. So it's a quadratic. You can apply the quadratic formula, or you guys should know what it's going to factor as. Let me factor it first for you. So obviously, there's going to be two brackets over here. One of them is going to be a 2s, and the other one's going to be an s. And then if I look at this right, I'm going to have a minus 1 and a positive 2. I believe that's going to get the job done. So the right-hand side, of course, won't change. And so now we're left with y equals 1 over s plus 2 cubed times 2s minus 1 minus 4 over 2s minus 1 times s plus 2. And so this is the next stage of the problem. Once you've taken the Laplace transform of the equation given to you and isolated capital Y, to get to your solution now, you want to take the inverse Laplace transform of what it is that you have over here. Now, taking the inverse Laplace transform is going to be a little bit tedious in this particular instance, as you're going to have to apply a partial fraction decomposition to each one of these two pieces. And the first one's going to be a little ugly, but there's nothing much we can do about it. So we're going to go aside over here, and we're just going to take a look at each one of these two rational functions and apply a partial fraction decomposition to them one at a time. So let's leave this as it is for the time being, and we'll come right back to it. Now, the partial fraction decomposition for this first problem is going to be the following. So I have s plus 2 cubed. So this is a linear function of multiplicity 3. So remember, you're going to have to build up to this multiplicity. So it's going to be a over s plus 3, or s plus 2 rather, plus b over s plus 2 squared, plus c over s plus 2 cubed, and finally plus d over 2s minus 1. And so in order to essentially calculate a, b, c, and d, we're going to, one at a time, we're going to compare the numerators. and then do the method of undetermined coefficients. So if I was to put the right-hand side on a common denominator, then the numerator of that expression would be a times s plus 2 squared times 2s minus 1 plus b times s plus 2 times 2s minus 1 plus c times 2s minus 1, and finally d times s plus 2 cubed. So in order to solve for A, B, C, D, and E, or just D rather, enough. So in order to solve for A, B, C, and D, we're going to pick intelligent values of S to plug in to this equation. For instance, if we let S equal to -2, then what I'm going to be left with is 1 equals C times -5. And so we can solve for C immediately as -1/5. Similarly now, if I let S equal to 1/2, what that's going to do is it's going to allow me to solve for D immediately. I'm going to have 1 equals 1/2 plus 2, so 5/2 cubed. So now you can solve for D. And I believe you would get 8/125. Let me just double check that real quick. Seems right. So we've got 2 out of the 4 variables that we need to solve for. Now, in order to solve for the remaining variables, you can just put whatever your heart desires for S and solve a system of 2 equations, 2 unknowns. Have a look. So I'm going to go ahead and plug in S equals -1 and S equals 0. So start with S equals 0. Now if I do that, I'm going to have 1 equals, if S is 0, then the first term is going to become -4a. The second term is going to become -2b. The third term, well, we know C is -1/5 times -1, so it's going to become +1/5. And our last term is going to become 8/125 times 2 cubed, which is just 8. So that's going to be our first equation. Let me just go ahead and rewrite this equation. So I'm going to go ahead and rewrite this as 4a plus 2b equals 1/5 plus 64/125. And I'm going to bring the 1 over as well, so -1. So it's going to give me -36/125. Now I'm going to go ahead and plug in S equals -1. And if I do that now, I'm going to have 1 equals. If I plug in -1, then the first part just becomes 1. And so I will get -3a. The next one is going to become -3b. Next, I'm going to get +3/5. And then plus 8/125. And so let me rewrite this equation as well as 3a plus 3b equals 3 over 5 plus 8 over 125 minus 1. And that gives me minus 42 over 125. So what I can do now is simultaneously solve the first and second equation, right? I'm going to solve this one and this one as two equations, two unknowns. I'm obviously going to expect you guys to know how to do this. And I'm just going to calculate the answer here in my calculator. So if I do this, I get A to equal to negative 4 over 125 and B to equal to negative 2 over 25. And with this, we can go back and kind of update our partial fraction decomposition. So let's do that. Or instead, before we do that, let's just go ahead and do the partial fraction decomposition on the second piece as well. Might as well get that over and done with. So minus 4 over 2s minus 1 plus s plus 2. So forget the minus 4 for now. Just say 4. The second one is 4 over 2s minus 1 times s plus 2, which gets decomposed as a over 2s minus 1 plus b over s plus 2. Now this one is easy enough to do quickly. So comparing numerators, we have 4 equals a times s plus 2 plus b times 2s minus 1. If we let s equal to negative, or let's just say positive 1/2, we will get 4 equals 5 over 2a. And so a is going to be 8 over 5. Similarly, if I let s equal to negative 2, I'm going to have 4 equal negative 5b. So b is going to be negative 4 over 5. And so that's that. So let me just quickly double check this. And it looks good. Okay, so we can now rewrite y. So going back to where we were before we applied these partial fraction decompositions, we know that this y now that we have at the top of the screen can kind of be rewritten. So that's precisely what I'm going to do now. I'm going to go ahead and rewrite y, capital Y, as, so in the first case, a was minus 4 over 125. B, I believe, was negative 2 over 25. C is minus 1 over 5. And finally, D was 8 over 125. And then for our second piece, we have A as 8 over 5 and B as minus 4 over 5. Now, A was over 2s minus 1, and B was over s plus 2. So, before taking the inverse Laplace, I suppose there is a little bit of simplification that can take place over here. we should be able to realize that this guy and this guy can be added up. Similarly, these two can also be added up. So let's do that real quick, and then we're almost there. So minus 4 over 125 minus 4 over 5 is going to give me an ugly number. I get minus 104 over 125 over s plus 2. The next few terms are going to remain as they are. And then 8 over 125 plus 8 over 5 gives me 208 over 125. And so now it's just a matter of taking the inverse Laplace of each one of these 4 terms using your cheat sheet. And so you guys should be fairly fluent in being able to do so. For instance, like the first one you should almost have memorized. The first term is just going to become negative 104 over 125 e to the negative 2t. And so this is no longer capital Y. This is going to be little y of t. Now, in order to get the second one done, you want to kind of apply a little shift. You want to let the s become s minus 2. And if you do that, then you should understand that there's going to be an e to the minus 2t that pops out. So we have 2 over 25. What I did in green is going to create an e to the minus 2t term that pops out in the time domain. You should be aware of this. But if we apply this shift, then we just have 1 over s squared, which you should know is going to become a t. And so you're going to repeat this process again. You're going to have minus 1 over 5. And then the same shift is going to create an e to the minus 2t term. And now, all that remains for this third term is 1 over s cubed. And so you should understand how to take the inverse Laplace of 1 over s cubed fairly clearly. I mean, it's nothing more than this guy right here. So recognize your n to be equal to 2. And so you're going to need a 2 factorial on top. So put a 2 factorial on top, but also divide by 2 factorial on the bottom. All of these are very simple things that I'm expecting you to understand. So this 5 is actually going to become 5 times 2, 10. And there's going to be a t squared showing up here. And for our last term, I'm going to rewrite the denominator as 2 times s minus a half. And if you can see that, then this is going to become 208 over 250 e to the power of 1/2 t. And so there you have it. Barring any silly algebra mistakes, this should be the solution to the problem. I'm hoping that you were able to get here for the most part on your own. Like I said, I did this kind of on the fly, so there is a chance that I made an algebra mistake, but you should be able to catch that. And so there you go. That should be the solution to the problem. I hope this tutorial helped out.